Welcome to this lecture. Today we are going to deal with these topics little quickly but in detailed approach. My name is Gunjan Subedi and as always I'll be guiding you in this topic with practical explanation and examples when necessary. Before starting, let me kindly remind you to subscribe to my LINEARITY, which is my initiative to deliver free and quality professional education to your screen. Tools to investigate in MSA or Measurement System Analysis. In this lecture, we will study some tools to investigate in MSA. We will have a short glance on these terms. These terms are very important from the perspective of Certified Quality Engineer and Quality Manager certifications too. Before that, let us learn some terms: true value, accuracy, and precision. True value is the value of measurement done with perfectly working measuring instrument or measurement process without committing any errors on measurement. Accuracy is the degree to which result of a measurement, calculation, or specification conforms to the true value or a standard value. The degree in which further or repeated measurements show the similar results is the precision. There is a marked difference between these two terms. Accuracy is the degree of closeness to the true value, whereas precision is the degree to which an instrument or process will repeat the same value. Based on accuracy and precision, we may encounter one of the following four scenarios. Data may be accurate but not precise. Data may be both accurate and precise. Data may not be accurate but precise. Data may not be accurate nor precise. Again, accuracy is the degree of closeness to the true value and precision is the degree to which an instrument or process repeat the same value. Let us look another term, bias. Bias is the difference between average or mean observed value and the target value. When we over or underestimate the value of population parameters, we fall into bias. Let's understand this with a scenario. Here suppose the true value of thickness of pipe is lot smaller than what we have measured. The thickness may be very less or significantly less than the true value. In that case, the difference between true value and the observed value is called bias. If the true value is unknown, it can be calculated by averaging several measurements with the most accurate measuring equipment available. There is another term, linearity. Linearity is a change in bias value within the range of normal process operations. It is the difference in the observed bias value through the expected range of measurement. Stability is a resistance to change in measurement bias over a period of time, or in simpler terms, it is the change in bias of the measurement over a period of time. We already studied about repeatability and reproducibility. If not, repeatability is the measure of the effectiveness of the tools being measured. The variation of the measurements obtained by a single operator using the same tool to measure some characteristics is called repeatability. Reproducibility is the measure of operator variation. The variation in the set of data collected by different operators using the same tool to measure the same part characteristics is called reproducibility. So what is the difference? Repeatability is the variation in measurement due to measuring device. It is the variation observed when same operator measures the same part repeatedly with the same device. And reproducibility is the variation due to the operators and the interaction between operator and the part or what he is measuring. It is the variation of the bias observed when different operators measure the same parts using same device. Well, we have come to the end of the lecture. Let me check your knowledge before moving on next section because this is quite really important. Here in this picture, the arrowman has pointed the arrows in the following points in the dart. Which of the following scenario best describes this situation? Both accurate and precise, accurate but not precise, precise but not accurate nor precise. Yes, in this case, the data points or these points of the dart are precise because the arrow points are gathered together in the dart but haven't reached the center or say true value that is being targeted. In this case, we can say that arrowmen or arrows shooted are precise but not accurate. Second scenario. Ramsey measured the bias between the true and observed value over the period of time, and he noticed that the difference between true value and the measured value has increased over the time. What term do you refer to address this change in bias over the period of time? Is it stability? Is it accuracy? Is it reproducibility? Or is it linearity? Well, the answer is pretty clear. As the bias value has changed or say increased over the period of time, in this case, we are referring to stability. Stability is change in bias value over the period of time. Before ending this lecture, let me remind you to join my Lean University's premium membership and enjoy a total free access for limited time inside my Lean University's online library and get tons of free courses, free books and lecture topics on project management, Lean and Six Sigma, operations and supply chain, productive and preventive maintenance, quality maintenance, data science, industry and sales management, Agile and Scrum, Kaizen or continuous improvement, and much more totally free. No strings attached. As we have limited seats, only the early subscribers will be given open access inside the premium membership, and remember, it's totally free. Please subscribe and share the video if you share the common belief that professional education should be accessible to all.